Would you take a look at that problem? You did one like that just recently. Look at the size of that. That's amazing. Hi, I'm David. I'm going to try to help you solve exponential equations. But right now, let's look at the logarithm one we have in front of us here. We wanted to maybe do a single, logarithm equal logarithm trick, but we weren't able to do that. And so we had to get to a single logarithm right here, a single logarithm, and then do that circle trick, basically getting out of logarithm format or mode and into exponential mode. And then we did some really cool quadratics to finish it off too. What a great problem. If you're able to understand this and start to be able to do this, you are more than college ready. You are very impressed. Very impressive. Let's try to use, I'm going to keep this in mind. Let's try to do something similar. So here we go. I would like to solve an exponential equation. An exponential equation is when the exponent has the variable, when our variable x is in the exponent. So our variable x is up here. It's superscripted. I kind of joke and say it's like stuck in a tree. It's how do we get it out of the tree? And I hope somebody says shake the tree. Yeah, and it would drop down and maybe an x would be at base level. Remember, base level. Think about that. So this is the difficulty. How do we get the variable out from here up in the exponent? Now, I want to remind you of just all the functions you've learned. Like, could you square root this? No, that won't do it. That's not the inverse function. No. Do you think we could maybe square both sides? No, that won't work. That's not the inverse function. That won't get x out of the exponent. How do we get that out of the exponent? Right? And so you've worked with a lot of functions before, and now you're getting used to this whole idea of undoing those functions. So here's the key. We're going to use the exponent rules. But whenever I tell people, this goes to the base and this part goes up to here, people forget. So I created phrases like circle trick and stuff like that. Well, yeah, I've got a phrase. I know. You're waiting for it, aren't you? Look, a variable's stuck in the tree. A logarithm will set it free. Yeah, that's it. That's going to be the core of what we teach today, what my main part of my lesson is today. So if I was to solve number 33, find what x makes this true, I could probably guess and check this because I think it's kind of easy to get from 2 to 8. And on that note, I could rewrite this in common bases and do that trick we talked about. So you might see if you set the exponents equal to each other, what's that, an 8 that's going to make that true? I think it's an 8. So we already know the answer is going to be x equal 8 from the common base idea. But let's try this logarithm idea. Okay, if you haven't written it down yet, write it down. It's supposed to be in your notes. Have a title. Put down today's date too. It's a good idea. So check a look. I am going to do a log. I can do a log base 2 because it matches the 2 base right there. But on my calculator, I have a log that looks like this, log right here. And so that's log base 10. So I think I'm going to use a base 10 logarithm based on the fact that that's what's on my calculator. So I'm not going to do a log base 2. I'm going to do a log base 10. And remember, I don't even have to write a base 10 there. It's understood to be it. And on the other side, we'll make this equal to a log base 10 of the 8. That's trying to squeeze it in. Maybe I should do this on the right side so I don't clutter it up. So we're going to log both sides. And we're going to rewrite it. So now I've got log. Okay, I'm not going to write the base 10. It already is base 10. 2 x minus 5. This is the exponent. And over here, I've got log of 8. Simple. Just log of 8. Which is something I can find on the calculator if I wanted to. Log rules. Yay! We learned those log rules recently. And this is another good reason why. Magically brings that exponent down in front. And yes, we did it. We got x out of the tree. we got the variable out of the tree. How did we do that? We did a log on both sides and did log rules. Now, this is hard, I think, at your age when you're learning this, so I really want to give you some tricks here. Log 2 some decimal number, okay? Some just, here, I'll show you. Log 2, I'm just going to turn the calculator on here, and I'm just going to go, let's see if I can turn the calculator on here. Let's see, boom, I'm going to go on, I'm going to just do log, and I'm just going to do 2. And I'm going to hit, whoops, hang on, I'm going to hit enter. I didn't want to. Hang on, I blew that. Let me back that up and delete that. Okay, I'm trying to show this on the calculator and I can't see it. There it is. See how it's just some decimal number? Log 2 is just some decimal number. So I need you to kind of box it into a parentheses and realize it's just some, and this is key, some rounded decimal number. Like we've seen that in some number files. Like that number probably goes on for a long ways, right? It might be even an irrational number. Show you what log 8. What the heck's a log 8? Close parenthesis. I didn't close it on the other one, but it does it automatically on the TI. Look, it's just some other number, right? Right? It's just some other number. Now remember, it's asking 10, base 10, 10 to something equals 8. Well, 10 to almost 1 kind of makes sense that it's equal 8. If you understand our circle tricks with evaluating, then it makes sense then that that number's just basically a little less than 1. Okay, so keep that in mind. These are just multiplied numbers. So look at my steps to undo here. Look at my steps. I'm trying to get x by itself. It's got some weird decimal multiplier and an add, subtract 5. So let's divide by log 2. And I write it like, you know, it's just a thing. Okay. And then I'm going to add 5 and we'll have the answer. We'll have the answer. Let's take a look. You ready? Divide. Please remember that the 8's inside the log function and the 2's inside the log function. So you can't divide the insides, just some misconceptions that are out there. You got to take a calculator out for that one. And then we're going to add 5 and then we'll have an answer. So now we grab our calculator and we're going to do just that. Look, I have log 8 on the screen already. Let's divide by log 2, close the parentheses, and I'll just hit enter, do it a piece at a time, and then add 5. And yeah, look, we knew what this answer was. It was 8. Big lesson here. Variable in the tree. A logarithm will set it free. I'm going to move my picture up there, and let's do the other one. Okay, so now we have 8 to the minus x. So at this moment, when writing the problem down, you make note, the variable's in that awkward position, up in the exponent, superscript, even has a negative on it. If you're thinking negative exponents flip, hey, that's clever, but we still would have x in the tree up in the exponent. Okay, can we even do a common base? Can you make this both a base 2? No, not easily. So this is why you need to know this trick. This trick is used in science all the time because so much growth occurs on exponential graphs, okay? So let's do this one. You ready? You're trying to figure out what x you need to plug in there to make 1.2. Wow, 8 to what makes 1, and it's negative? This is going to be an interesting number. I can't imagine it's big. So let's see. Log both sides. Log 8 to the minus x is equal to log 1.2. Remember, log of 1.2 is just some weird decimal. Negative x comes down, becomes a multiplier of log 8. That's a 1.2, sorry. Looks a little messy in there, 1.2. All right, now remember, this is just some weird multiplier. You've seen it. You know log 8's like 0.9. We just saw that. Cool. What do I need to do to get it by itself? I think we need to divide by a log, right, and multiply by a negative 1. Cool? All right, let's do that. Negative x is equal to log of 1.2 over log of 8. You should look up change of base formula for logs. It's kind of cool. You might enjoy that. And then it's negative of that answer. Okay, so I'm going to take a calculator out and get that answer, and I'm just going to round it to hundredths. It's a nice 2 decimals is a common place to round it to. So let's take our calculator out. Let's do log 1.2 close parentheses divide log 8 close parentheses enter. It is 0.0876, so I'm going to round that to 0.09. 0.09, and there's a negative on it. Cool. And double underline. There you go. That's using a logarithm. Like I said, very common in science. Very common in science. If I move too fast, remember, you're on a video. Back it up. Go look at it. Go write it down. All right, say it with me. Please, please say it with me. You need to say it. You need to remember it, and by saying it, you remember it. Why did I write it in a funny way? That's not sets it free. Okay, you ready? Variable in a tree. Logarithm sets it free. It's beautiful poetry. Let's make up a problem. You ready? Let's make up a problem. Let's make it a little bigger. We're going to do, let's say, I don't know, how about 3 times 2 to the x plus 1 minus, no, let's go plus 6 equals, I don't know, how about 240, right? Here's the question. There's some exponential growth, right? An up 6 graph, exponential curve, got a multiplier of 3, so it's growing really fast, right? We're just huge, fast growing curve. We're curious when this curve hits 240. Understand the math at what we're doing. Don't just move numbers around and variables around, okay? Make sense of it. How many steps to solve? Can you see it? Can you see it? Pause the video. How many steps to solve? Pause the video and count them. See if you're right. Ready? 1, 2, 3, 4. I think 4. I'm going to subtract the 6. I've got to divide by the 3. Please remember, you can't do 3 multiplied to 2 there. Another major misconception. So many ones around here. You've got to be meticulous in doing this homework. Cool? And then once we divide by 3, that 2 to the x plus 1's by itself. So we're going to log both sides. And then we're going to subtract 1. That should get me home. Let's see. 3 times 2 to the x plus 1. That's a times in there. 3 times 2 to the x plus 1. If I subtract 6, that's equal to 2, what's that? 34. I'm then going to divide by 3. Too many times I see students set their pen down and grab a calculator. Don't. Grab it at the end. Best lesson I ever got from a teacher, math teacher in high school. Don't pick up the calculator until you're done. You're not done yet. Just leave it. What do we have to do? Log both sides? All right, let's do that. I'm liking this. How about you? Once you get over what a log is, just some sort of decimal, some sort of exponent to satisfy the evaluation. Look at that. We're going to bring that x plus 1. It's one chunk. Sometimes I put an x parentheses around it. We're going to bring that down in front as part of that log rule. So technically, I had another step in here. You could argue this was another step using the log rule. So now it might be 5 steps. Let me just write 34 divided by 3 this way, sideways. Okay, you ready? Last 2 steps. Divide. I'm having trouble breathing. It's a lot of work, teach. 234 divided by 3. And big divide by log 2. And last step is subtract. And so here's what I need you to do on the homework. Box the exact answer first. Then take a calculator out and get some weird decimal answer. Okay? Does that make sense? So now we're going to take the calculator out. So I got my calculator out. Be very meticulous typing it in. I got to close the parentheses on each log. To even be safer, after the log divided by log, I hit enter and then minus 1. 5.29 rounding to 2 decimals. 5.29. Does that make sense? 5.29. Yeah, if you check it, I think that makes perfect sense. So I'm David. I hope this helps. Variable in the tree? Say it to me. Logarithm sets it free.